This is topic 3.8, human populations, and we are finally, after talking about all these biomes, all these other species, all these animals, we are finally talking about the human. So let's do this. Before we get too far into it, I just want to introduce you to how do we calculate some of these rates that are important when we're looking at human population growth over time. One example is our birth rate. It's very important we know how to calculate that. So in order to do that, we're going to take the number of live births and we're going to divide that by the total population. Normally this happens at mid-year. So nice and simple. Live births divided by total population is going to give us a percentage or decimal number. We then need to multiply this by 100 to get our percentage. Most of the time, very important, most of the time we are working in percentages, not decimals. There's also something called the crude birth rate. Sometimes people see 3% birth rate and they're like, I don't know what that means. And so we turn it into a number that people are more comfortable working with. And it's reported as a number of births per 1,000. Pretty much what we do is we take the same thing. We do our live births divided by our total population, and then we just multiply it by 1,000. So that means 30. 30 live births per 1,000 individuals. So if you ever see crude birth rate, that's what we're talking about there. Death rate, same thing. We're going to take the number of deaths divided by total population, multiply that by 100 to get our percentage. Crude death, we're just going to multiply that by 1,000. Technically, this percentage, if I get, if it's 3%, that is 3 in 100, but people don't always realize that. So if we multiply it by 1,000, that would now be 30 in 1,000. So again, a little bit easier to understand. Okay, let's talk about humans. For most of the past 100,000 years, humans have lived as these hunter-gatherers. We would hunt, we would gather, we weren't really growing that much, and our population was so small that we didn't really have a massive impact on the environment because we weren't big enough, we weren't profound enough to have a massive impact on the environment. However, about 12,000 years ago, we discovered agriculture. This is a massive movement for our population. This led to 3 things. We were now able to alter the environment. We were then able to build cities, protect our food, store our food. And then we started to increase. Our population increased because of so much food. We were able to create food for ourselves instead of just hunting it down. So these 3 things are very important as they relate to agriculture. This intensive agriculture has caused our population to go from 5 to 8 million to 60 to 70 million in just 5,000 years. So you can see these increases as we increase and increase and increase and increase, growing so much. So agriculture happened, we started growing, then we started learning how to plow and irrigate, so much more. Then all of a sudden, bubonic plague, that killed off a bunch, but then this was a massive piece for most populations, was this industrial revolution that began. And after that, we just grew and grew and grew from there. So I'm sure many of you have seen this. We are going through exponential growth. This is a beautiful J curve. So we went from kind of the start of our population and then got greater and greater and greater. And here we go, 1998, 2010, 2020, and they're expecting we'll be up at close to 8.5 billion, which I know we're already there. We're already at 8.2 billion. So our population is growing and growing and growing much faster than this model is even predicting at this exponential growth. What we have to remember, though, is that we are species too, and every single species has a carrying capacity. So the question is, what is our carrying capacity of Earth? So far, many scientists have disagreed on this. They think that maybe it's going to be around 10 billion because we're currently experiencing this exponential growth, and eventually we're going to go overshoot our carrying capacity, and there will be a dieback. In 1798, T.R. Mathis, he made this observation that we were just developing resources at this linear rate, and our population was increasing at an exponential rate. So these are our resources we're developing. This is our J curve for our exponential growth. And eventually we're going to hit this point of crisis called the Malthusian catastrophe. Anyway, it's pretty much we're going to overshoot our carrying capacity one day. And the dieback will include famine, war, decline in population, etc. So who knows? Clearly, our population is growing at this exponential rate, but there are still factors that affect it. We are not growing at our biotic potential because of some of these societal factors as well. So obviously, birth rate's going to affect it, death rate's going to affect it, education affects it, infant mortality, age of marriage, and nutrition. These are the 6 factors, and we're calling these societal factors because they're societal factors that not all species experience that are very unique to humans. All right, so clearly, if our birth rate is high, then we're going to increase our population. If our birth rate is low, population is going to decrease. If our death rate is high, then our population will decrease. If our death rate is low, then our population will increase. If the rate of infant mortality is high, that means we've got infants dying between the years of 0 and 5. If that is at a high rate, it's going to decrease our population. If it's at a low rate, it will increase the population. Nutrition, very self-explanatory. If nutrition is at a high rate, we're going to increase. Low rate, we're going to decrease. Education of women. This is something I would say I definitely want you looking for. When we talk about some other indicators, education of women has the largest impact on the growth rate for a population. When we increase our education of women, then actually our population will decrease. And when we decrease the education of women, our population increases. And then finally, age of marriage. If we marry at a much later time in life, if that's a high year or a later year, then we're going to decrease that population because we're not producing as many children most of the time. However, when we marry at a lower age, we're going to increase the population most of the time because there's more years for that reproduction to happen. Now, we cannot forget these human populations do have limits. We do have a carrying capacity as humans. And as I mentioned before, this Thomas Mathis came up with this idea of when this could happen. We are limited by those societal factors, but we're also limited by our density independent and density dependent factors, just like all other populations. So independent factors, storms, fires, heat waves, drought has a massive impact on the human population. And density dependent would be disease transmission, territory size, food availability, and access to clean air and clean water. Just like any other population, we can increase, reproduce at our biotic potential, have an overshoot, back and forth until we get steady at our carrying capacity. I just quickly want to go into these environmental problems again, and these are density independent. Storms. We've seen storms having a massive impact on housing, availability of housing. When a storm comes through or flooding comes through, it can destroy a lot of housing, causing the displacement of people. Fires are another example of that as well. Droughts lead to the inability to farm, and that lowers the amount of food that can be produced, causing, again, human population to have to maybe move. And when we talked about this before, if I'm talking about one region and the human population moves out of that region, it is considered extinction. And then same with heat waves. Heat waves are causing a lot of people to start moving north or south away from the equator. So there was a study done with storms affecting the human population. So we had a lot of hurricanes from 1980 to 2012. They looked at those and they realized that the high density counties, the areas where people were living that was very high density, had a drop in population. This was because there was damage to homes, economic loss. Maybe they moved away because of these storms and they realized, hey, I can get better economic opportunities elsewhere. So they've left these areas where we had high hurricane occurrences to different areas for reasons of the damage and the economic loss and the better opportunities. That counts towards a population drop in that specific area. And this is something that AP could test you on. All right, another subject, and especially in terms of human population, we use this thing called doubling time. Doubling time is the amount of time for a population to double at a constant growth rate. We're going to use the rule of 70. This is something you need to memorize. Let me say it one more time. You need to memorize this equation. 70 divided by R is our doubling time in years. So R is going to be our growth rate of the population. When we do these calculations, our R value needs to be in percentage. Very important, not decimal. Keep it in percentage. All right, let's try one together. If a country has a population of 100,000 and a growth rate of 1.25, what will be the doubling time of this population? Now, if you look at this equation here, the only value you need is R. That's it. So they threw in this 100,000 as a distractor. Not needed at all. All you need is this R value here. So we're going to go 70 divided by 1.25, and that gives us an answer of 56 years. Question number 2. If country has a population of 8.4 million in 2018 and an R value of 2.27, what is the closest population in 2050? Don't get overwhelmed by this. Just start again with 70 divided by R equals a certain amount of years, which is my doubling time. Okay, so let's just start by calculating that. That will be our first step. So find our doubling time. 70 divided by 2.7 equals 3.8 years. Wonderful. But then how do we apply that? This question is saying if the country has a population of 8.4 million and an R in 2.27, which is the closest in 2050. Well, now we need to find the difference between those years. Is it 30.8 years? That will help us get a better understanding here. Now I'm going to subtract those two. and figure out that, the difference between these two is 32 years. That's very close to my 30.8 years. So that means we're going to allow the population to double once. Now, looking at my answers here, I'm looking at this and I'm like, Now, remember, you will always get a multiple choice type question like this. We're not expecting you to get the exact population through calculations. This is more of a rounding step. So if it was 8.4 million in 2018, it is going to be doubled. And when we double it, that's going to give us 16 million, which is really close to 17.2 million. Because we're going longer than that 30.8 years, we actually see a difference of 32 years. That means it's going to be a little bit larger than that 16.8 million. All right, question 3. A country has a current population of 144 million and a growth rate of 0.93%. Remember, in your brain, this is our value. How long will it take for the population to reach 575 million? So it looks like I'm going to be doing some doubling here. My equation, again, 70 divided by r equals our doubling years. How much time does it take for the population to double? So let's just do that math real fast. Let's just do that. So our doubling years is 75.62 years. That's super important. Okay, so that's how many years it takes to double. Well, if I double this population, I'm going to get a value that is 288 million when I double it. That's not what I'm looking for. I'm looking for 575 million years. Well, what if we double it again? Very important, we're not going to add 144 to it. No, we're going to take 288 times 2, because that's what doubling is. Now we get 576 million, which is very close to my 575 million. So because it took 2 of those doubling periods, I'm going to take my 75.26, my doubling years, and multiply that by 2 to get my answer. So our answer here is C. All right, some quick takeaways. This should be memorized. Rule of 70 needs to be memorized. Calculation should always be done with the percentage. That's very important, not the decimal. Always look at the question to see how it's being asked and how to calculate that correct answer. And calculators are not required. Don't forget that, but they're always helpful. All right, that's a wrap. Thanks, guys.